MRI physics for future MR techs. Step 1, you have to replace your core mental model. X-ray thinking. Image equals how much radiation is absorbed. MRI thinking. Image equals how much signal is emitted. Step 2, what MRI is actually measuring. Instead of photons passing through the body, MRI measures hydrogen protons responding to energy. Your body is full of hydrogen, water, fat. Mine's fat. Each proton behaves like a tiny magnet. Step 3, the magnet B0. Think of the MRI scanner like a super strong, always-on magnet. When a patient goes in the magnet, the protons align with the field, and a small net magnetization forms. This is your starting signal source. Step 4, RF pulse equals exposure. In X-ray, you press the exposure button and photons go through the patient. In MRI, you send an RF pulse into the patient. This excites protons, knocks them out of alignment, and creates a measurable signal. This is your exposure equivalent. Step 5, signal instead of attenuation. After RF is turned off, the protons relax and they emit energy. That emitted energy equals MRI signal. A coil, like a detector, picks it up. Step 6, MRI contrast. This is the big difference. X-ray is about bone versus soft tissue and based on density. MRI contrast is about how tissues behave over time. The two main behaviors are T1 recovery, how fast tissue resets after excitation, and T2 decay, how fast signal falls apart. Clinical translation. Fat has a short T1 and will be bright on a T1 weighted image. Water has a long T1 and is dark on T1. And water has a long T2 and is bright on T2 weighted images. Step 7, your new technique factors is, instead of KVP MAS, you control repetition time, TR, and time to echo TE. TR, repetition time, like how often you expose. Short TR, T1 weighting. Long TR to less T1 effect. TE, echo time, like when you measure signal. Short TE, less T2. Long TE, more T2. Let's do some quick mapping. X-ray or an MRI. Step 8, sequences of use protocols. In X-ray, you use a technique chart. In MRI, you use pulse sequences. Common ones you'll use. T1 is for anatomy and post-contrast. T2 is for pathology, fluid equal bright. T2 flare removes CSF and highlights lesions. DBY is for acute stroke, most critical. And susceptibility-weighted imaging, SWI, or GRE T2 star is for blood hemorrhage. Step 9, why MRI feels hard at first. Because you're controlling time shot to physics, not just exposure. In X-ray, you are one shot done. In MRI, you are in a state of continuous signal building. Every parameter affects contrast, SNR, scan time, and artifacts. Step 10, the tech reality. You are constantly balancing image quality, scan time, and patient motion. Step 11, safety shift, critical. In X-ray, you are focused on radiation risk and safety. In MRI, you are focused on magnetic field and gradient field safety, always ensuring no projectile hazard, no unsafe implanted devices, and no RF heating. And reminding everyone with access to MRI, the magnet is always on. MRI is like listening to how tissues ring after you hit them with RF energy. Enjoy the process of learning in MRI, because you never stop learning and growing in MRI.